Ready. So yesterday we looked at nets and how to create them from 3D figures, and today we're going to look at how to calculate this surface area from these nets. But luckily it is just like our strategy when we find total area of composite shapes. It's just we're going to be breaking them from our 3D figure first. So let's take a look at this first problem and think about how we can start finding the surface area. Alrighty, so if we're looking at this net, I see first that it's going to be this broken up shape with a base that appears to be a square, and then four lateral sides that if we had pieced back together would create a square pyramid, right? We reviewed those 3D figures previously. So when we have one base and then all the shapes come together at a point, we know they are a pyramid. So if we are trying to find the area of this figure, let's think back on what we are trying to find within this space. So we know that surface area is similar to area, but we use it specifically when dealing with 3D figures. So if we're talking about the surface area of a solid, this would be the three-dimensional piece that we would cover both the lateral faces and the bases all together. So we already talked about how this is a square pyramid because we have that one base that's in the shape of a square, and then all four triangles that would fold up to the point of the pyramid. So let's go ahead and start thinking about the dimensions of each of these shapes in this net. So if the boxes on the grid paper represent a 1 foot by 1 foot box, we're going to label the dimensions of the net as we go through counting by 1 foot at a time. So if we look at this square and I look really carefully at my jumps, I see 1, 2, 3, 3 feet by 1, 2, 3, 3 feet. So we have our square. I'm just going to draw it over here so we have more space. 3 feet by 3 feet are the dimensions of the square. Now, I see that we also have triangles, so I'm going to use a different color as I count the dimensions of the triangle. Looking at the base is 1, 2, 3, 3 feet. And the height, remembering to go straight up and down to the tallest point, is 1, 2 full jumps, so 2 feet. Okay, it is very important that we check the dimensions of all four triangles. We cannot assume that all of these triangles are equivalent unless we are told that they are. So we have this one that's 3 feet by 2 feet. Let's draw this on our paper and go through to check each of the others. So 1, 2, 3, and a height of 2. So this one is a second or a repeat, so 2 feet, 3 feet. Okay, 3 feet by 2 feet. And then let's look at the last two. 1, 2, 3. And straight up and down, 1, 2. So I have a third one that's 3 feet by 2 feet. And let's check the last one. 1, 2, 3. And a height of 2. All right, so we have confirmed that all four of these triangles have exactly the same dimension, but once again, we cannot assume that, so we have to make sure we check them all. All right, so since they have the same dimensions, right, we're going to start finding now our surface area. So now that we've talked about what the surface area is, this shape is beginning to remind me of how we found the area of composite shapes. So how did we find the area of composite shapes? Well, when we couldn't use one formula to find the area of the entire shape, we had to break it up into these smaller shapes and find the individual areas first before adding them up. So let's go ahead and draw out our plan just like we did previously. Okay, so if we have our area of our square, and if we find the area of one triangle, I know that I would then have the area of the other four triangles if I simply multiply by 4, and that will get me the surface area when we add them all up. Alrighty, so now that we've drawn out our plan, let's go ahead and write our formula for each shape. So looking at our star chart, I know the area formula for a square is base times height, and the area formula for a triangle is 1/2 base times height. So let's zoom out a little bit more. So now we can begin substituting our dimensions into our formula and solving. So starting with the square, I know the base is 3 and the height is 3, which gives me an area of 9 squared feet. And then looking at the area for the triangle, I see it's 1/2 times a base of 3 times a height of 2. which would be 1/2 of 6. 1/2 of 6 is 3. So the area of this triangle is 3 squared feet, except we have 4 of them. So in order to find the area of all 4 altogether, I could add this 4 different times, or I could simply multiply it by 4 and see that the area of all 4 triangles is 12 squared feet. All right, so now we have the area of the triangles, we have the area of the square. How are we going to find the surface area? We need to still add these areas together, so I'm going to do that over here on the side. 9, plus 12 is 21 square feet. So let's go ahead and write this in a complete sentence. The surface area is 21 square feet. So we want to stamp one more time in our notes. Let's make sure we're writing down our steps. That the first thing we need to do is decompose this shape, break it up into similar shapes, and then find their individual areas using their formula. And then we can find the total surface area by adding them together. Let's go ahead and try one on our own.